Hello dear students, today we are in a discussion of resolving the vectors. We would like to resolve the vectors into its components. So think an object is placed on a horizontal surface and it has been pulled along the direction that is shown in the diagram. It is neither horizontal nor vertical, rather along the slanted line. And the dotted one representing the new position of the object as it has been pulled along that slanted line. So you understand the force has been acting on this object along the slanted line, inclined line direction, but the object is moving only along the horizontal direction. So obviously the object experiences a horizontal force, and that is what we want to find. What is the horizontal force the object experienced? It is F cos theta, and the vertical force is F sine theta. How? So see right here. The force F we drew along that slanted line. It made an angle theta with the horizontal. We drew the perpendicular on this horizontal line, so it became a right angle triangle. The horizontal is right here, the adjacent, and the vertical is opposite of this right angle triangle. F here is the hypotenuse. So you use now the trigonometric rule that sine theta equals to what, cos theta equals to what, and tan theta equals to what. So when we use this trigonometric rule, cos theta equals to adjacent over hypotenuse. Adjacent here is the horizontal line. So FH divided by F is cos theta. When we subject FH, we get FH equals to F cos theta. Again, when we are taking the formula sine theta, that equals to opposite by hypo. So opposite means the vertical. Along this vertical we consider the vertical force. When we are subjecting this vertical force, it is F sine theta. And you know that vector can be shifted parallelly. So the vertical line that I drew from the head of horizontal, that can also be drawn from the point where the force acts. So I just shifted the vertical force parallelly, so that from this particular point along the horizontal FH, along the vertical FV, and F is the resultant of FH and FV. Is it clear? Look at another example. The force here is still again acting along that slanted line, and along the direction to this vertical, the angle is known to us. This angle is given to us. So if the force is along the slanted line, that inclined direction, and it makes an angle theta with the vertical, then what component of F will be acting vertically, and what component of F will be acting horizontally? That's the question. So I drew it again. F is along the slanted direction. It made an angle theta with the vertical. So I just shifted the vertical line from the head of this F, and I made the right angle triangle. Since this is theta, that one also is theta, alternate angles. So the vertical line is nothing but an adjacent, and horizontal one is opposite. F itself is the hypotenuse. So whenever it is adjacent, look at the trigonometric formula. The cos theta equals to adjacent over hypotenuse. So when you are subjecting this adjacent, you get adjacent equals to F cos theta. Just have a look. Cos theta equals to adjacent divided by hypotenuse, this F. as a subject adjacent, it is hypo times cos theta, and this hypo represents the force F. It is F of cos theta. So along this vertical direction, F cos theta is acting. The vertical component of this force is right here, F cos theta, which is what we have seen just before, that vertical component of F was F sine theta. Right here it is F cos theta, depending what angle you have been given with. Have you been given with the angle to the horizontal or to the vertical? Depending on that, the horizontal or vertical will be either cos theta or sine theta. So you have to be consistent in this pattern, in this, the derivation, that when theta is given to some certain direction, that direction is representing the adjacent of that right angle triangle or opposite of that right angle triangle. Have a look to another situation. Here the object is along the inclined plane. The object itself is along the inclined plane, so its weight is acting vertically downward. The inclined plane where the object is, that plane makes an angle theta to the horizontal. So this weight is perpendicularly acting to the horizontal. Weight is always vertical and weight is perpendicular to the horizontal. When we considered the perpendicular of that inclined slope, the inclined slope, you see, perpendicular of that inclined slope, then what angle this perpendicular to the inclined slope makes with W, with weight? So just look at this geometric. Theta is the angle that the inclined slope makes with ground, with horizontal. If this is theta, weight makes 90 degree with the ground, with the horizontal. So in this right angle triangle, this one is 90 minus theta, and perpendicular to the slope is only theta. I'm drawing it once again. This is here the object. Weight is acting vertically downward. This is perpendicular to the slope. This is the angle theta, because inclined slope makes an angle theta with the horizontal. This is the perpendicular that I drew to that horizontal, perpendicular to the inclined slope line. That is what I labeled as adjacent. So I drew the perpendicular line from weight to that adjacent. So this became a right angle triangle. You see which one is adjacent, which one is opposite, and which one is hypotenuse. This became just a right angle triangle, the way we did discuss little earlier, that whenever it is right angle triangle, we do make use of this trigonometric formula: cos theta adjacent by hypo, sine theta opposite by hypo. Let's get back to this triangle. Let's label this triangle as OAB. Alright, so this is the right angle triangle. Triangle OAB is a right angle triangle where angle OBA is 90 degree and angle AOB is theta. Alright, so if theta is made along the direction OB, then cos theta is adjacent by hypo. And again, when we are subjecting this adjacent, what we get? We get hypo times cos theta. Here hypo is W, so this adjacent along the direction of OB is W cos theta. So what component of weight is acting perpendicular to this inclined slope? It is W cos theta. Check it out. It is W cos theta which is acting perpendicular to the slope. And theta is basically the angle that inclined slope makes with the horizontal ground. So parallel to the slope is just the opposite. I have shifted this vector from opposite, which is along the direction AB, to that parallel to the slope, which is W sine theta. So again, getting back to the problem that I drew here, so W sine theta is acting down the slope. Now let me give you one trick. You are not supposed to draw a right angle triangle, find out the adjacent, opposite, hypo, and then using this trigonometric rule every now and then, which one is cos theta, which one is sine theta, to find out just the component of the vectors. Then you will be proceeding to the real question. I mean, if you want to do this sort of things every time, then it will take a lot of time. So the trick here is, if the vector makes an angle theta with any direction, that direction is for sure adjacent. And adjacent means it is cos theta of that vector. Right here, F makes an angle theta along this horizontal leftward direction. So that is adjacent. This is F cos theta. F sine theta is always at 90 degree to F cos theta. And you must remember, F is the resultant of F cos theta and F sine theta. Let's go for the second one. Suppose the vertical force is given to us. It is, say, the vertical force, as we are very much habituated considering the vertical force as weight. So the vertical downward force is weight. It makes angle theta with this direction, little slanted. So since it makes angle theta with this direction, it is for sure adjacent. Since it is adjacent, it is for sure W cos theta. Once you know it is W cos theta, where the W sine theta should be acting perpendicular to W cos theta, so that the resultant is W. So this is how we draw. Case number 3. Here I drew the horizontal vector. The horizontal vector, it makes an angle theta with the slanted upward line. So since horizontal V makes an angle theta with that slanted line, that is obviously adjacent, and that is V cos theta for sure. Perpendicular to this V cos theta is opposite, which is V sine theta. It should be so much so that V is, the vector is lying in the plane of cos theta and sine theta. This is how you have to choose the cos theta and sine theta perpendicular to B. You must not choose the V sine theta in the other way around, in just opposite direction, the way I drew in every case 1, 2, and 3. You cannot draw it in the opposite direction, because in that opposite direction, if you drew, it means the resultant F, W, or V is not actually acting along the direction it is shown in the diagram. Okay, so in fourth case also, the tension makes an angle theta with the vertical. So the vertical one is T cos theta and the horizontal one is T sin theta. Got it, sir? Now, if you understood what I said, then this is a question for you. You have to find out the weight of this metal block, which is suspended and it is in equilibrium. You see, a stationary metal block, it is equilibrium. It is suspended at this particular point freely. There are two tensions acting, which are shown in the diagram in the figure, and what angle it makes with the horizontal also is stated. You have to find out the weight of this metal block. You have to resolve the vectors into its components, and then you have to figure it out how much should be the weight of the metal block so that it is stationary, it is equilibrium. Alright, do solve, let me know what answer you got, share it with us. Please, if you like this one, do comment so that I know actually it is helping you. Well, I mean, I need some motivation, isn't it? Thank you